All right, students. It's chemistry class, and I want us to treat this topic titled pH and pOH. I remember the last class we discussed hydrolysis of salt, and before then we've treated pH of solution. We said is a scale that measures the degree of acidity or alkalinity of a solution. Now let's quickly look at this calculation involving pH and pOH. And what you are seeing on the screen now are the various formula we are going to be using. Now, this one, I want you to take note of these first two, which says pH is equal to negative of natural logarithm of hydrogen ion concentration. Then pOH is negative natural logarithm of hydroxide ion concentration. Then we also have this, that pH plus pOH, the summation of pH and pOH gives us 14. So what you have here is just modification of this when you make H the subject, and here when you make OH the subject of formula. So let's get started. Now we're going to be treating some questions. Now the first question says that what is the pH of a 0.05 molar solution of hydrochloric acid? Now when you are faced with a question like this, you ask yourself, what is this? This is an acid. So take note of that. Then you write an ionic equation of the acid when it dissociates, that is when it splits. If you split this HCl, you are going to have H plus plus chloride minus, and you are going to do the stoichiometric relationship. In the balanced equation, we used 1 mole here to react with 1 mole here. That is, if you balance this, what you have here is an imaginary 1. What you have here is an imaginary 1. So this 1 mole of this gave us 1 mole of hydrogen. You will now do a relationship that since 1 mole of this gives us 1 mole of this, we are less concerned about the chloride because we are told to find the pH. You will now ask yourself that so 0.05 molar of HCl will equally yield 0.05 molar of hydrogen. It's a direct relationship. So definitely the concentration of hydrogen ion is still 0.05 molar. Then you use the formula which says pH equals to minus log hydrogen ion concentration. Don't forget, we are looking for the pH, and we already know the hydrogen ion concentration as this. So this is representing hydrogen ion concentration, so you substitute this value 0.05 molar. So let's move on. So if you change this to standard form, you have 5 times 10 raised to the power minus 2. Then what we have just done here is to open this bracket with this negative logarithm by saying minus log times 5, you have minus log 5. Now you know that your logarithmic rule, your multiplication changes to addition, so you have minus log 10 raised to power minus 2. You have to separate this with a bracket so that you don't mix up the signs. So if you press your calculator, log 5 gives you 0.6990. A minus is meant to be here, it's missing. You have to put the minus. It's a typo error here. Then to deal with this, your knowledge of mathematics had to come into play. This minus 2 can come to the back here. You are familiar with this in mathematics. Then times log 10. And you know that log 10 is 1. You should know that log 10 is 1. And mind you, there is a base of 10 that we've been ignoring here. because it is expected that when a natural log reading is not carrying any other base, it is assumed to be 10. So log 10 is 1. So minus 2 times minus 1 gives you plus 2. I'm sure how this transform to plus 2 is clear. If it's not clear, let me know. But that is it. Now I told you there is a minus here that was missing, so you have minus 0.6990 plus 2, which will give you 1.3. So our pH is 1.3, and that is expected because the solution we are dealing with is an acid, and an acid is expected to have a pH below 7. And being a strong acid itself, that's why the pH is this low. The lower the pH, the stronger the acid. So let's take another example. This one says, what is the pH of 0.05 molar solution of tetrahydrosulfate 6 acid? Now, just as I told you, you will write the formula of the acid, you will ionize it. If you ionize H2SO4, you have 2H plus because of the 2 here, plus sulfate. Then you write the mole relationship. This is 1 mole, gives you 2 mole of this. We are less concerned about the sulfate because that's not what we are calculating. Now, the relationship here is 1 mole to 2 mole. Then you now ask yourself, then 0.05 molar of the acid. This value given is for the acid. What will it now translate to? Since they combine in ratio 1 to 2, then the concentration of the hydrogen ion will be 2 times that of the H2SO4. That's why we have 2 times this to give us this. So this is the concentration of the hydrogen. What we are doing actually is to calculate the unknown from known. What is known is the concentration of the H2SO4. What is unknown is the concentration of the hydrogen ion. And since we know the stoichiometry relationship between them, that it is 1 mole to 2 mole, then whatever the concentration of the acid is, we can now decide on that, what the concentration of the hydrogen. Since it is 1 to 2 here, that's why we have to multiply this by 2. So having calculated the concentration of the hydrogen ion, you substitute it here, which is 0.1 molar. If you change this to standard form, it gives you 10 raised to the power minus 1. Minus 1 moves to the back, so you have minus 1 times minus that was already here, log 10. Minus times minus gives you plus. Log 10 is 1. That's why the pH is 1. I hope this mathematics is clear. Let's move. Now, this is another question here. What is the pH of 0.02 molar sodium hydroxide? Now, this example now, we are given base, not an acid. But the question is asking us to calculate pH. And you know that if a base you ionize, it will split into sodium ion and hydroxide. There is no hydrogen ion here. So what you will calculate is the pOH. What you will calculate is the pOH. But the question asks for pH. But you can calculate the pOH, then you will now get your pH from your pOH, since we already said pH plus pOH is equal to 14. So if we do the ionization, this is what it will give us. And the relationship between the sodium hydroxide and the hydrogen in terms of mole is 1 to 1 in the balanced equation. Definitely 0.02 molar sodium hydroxide will yield the same value for the hydroxide. So our concentration of hydroxide is 0.02 molar. Oh, what should be here is OH. pH is minus log OH concentration. What should be here should be OH. So you now substitute this value here. So if you change it to standard form, you have 2 times 10 raised to the power minus 2. Just as I said earlier, open the bracket with this minus log. So you have minus log 2 plus minus log 10 raised to the power minus 2. If you press log 2, you have 0.3010. Put back your minus plus. If this minus 2 comes to the back, you have minus 2 times the minus that was already here, log 10. Minus 2 times minus, that's 2, because log 10 is 1. So if you do the mathematics, you have 1.7 as the pOH. Why are we using pOH for this? Because we are dealing with a base. You remember this example for the acid, we didn't use pOH, we used pH because we are dealing with acid. We didn't use pOH, we used pH because we were dealing with acid. So take note of that. Now we've gotten the answer for the pOH to be 1.7, but what the question asks us to calculate is the pH. So just bring that formula that says pH plus pOH equals to 14. pH we are looking for, pOH we've calculated to be 1.7. So if you subtract that, you have 12.3 as your pOH, and it is expected because it's a base. So the pH of a base is expected to be above 7. That's why we have 12.3. And the higher the pH, the higher the concentration, the stronger the base we are talking about. And sodium hydroxide is a strong base, so it is the value given here is actually expected, the value that we got. So you can see the comment, the pH of the solution is 12.3. because sodium hydroxide is a strong base, it makes sense that the pH is above 7. Yes, the pH is expected to be above 7. Now let's look at the last example. We said a sample of gastric juice has a pH of 2.5. What is the hydrogen ion concentration in this equation? Now all this while we've been calculating pH, pOH, but this question is asking us to calculate the hydrogen ion concentration. So we have been given the pH to be 2.5, so if you substitute this, equals to minus log 10 hydrogen ion. Now just mathematics, just divide both sides by minus log. If you divide this by minus log, you'll be left with hydrogen ion concentration. If you divide this by minus log, you have this. Now our log now is now inverse. What we have here is now inverse of log, and you've been told that inverse of log is anti-log. So what you are just going to do is to find the anti-log of minus 2.5. Please, when you are finding this, press minus second function log of minus 2.5. You have this value, 0.03 molar hydrogen ion concentration. So all the calculations I've done, I will advise you to write it out into your notes, following each step painstakingly, so that you get it better. It's easier just looking at it here, but when you write it out, that's when you yourself will develop, you have a proper grasp of what I'm talking about. So that is that about pH and pOH. I have some class exercise here for you, so you can see. I want you to take your time, ionize properly, and deal with the question accordingly. If you are stuck anywhere, just let me know. Thank you.